Universal School online class. Remember to subscribe to our YouTube channel cost-free and believe in yourself. And remember that all scholars, teachers care. Last week, we considered trigonometrical ratio graphs, whereby we're able to plot the graph for cosine and sine of angles. Today, we'll be considering how we can solve simultaneous equations involving sine and cosine angles. In this example, we have equation 1 as y equals to cos x and equation 2 as y equals to sine x, where x range from 0 to 360 degree and 30 degree interval. That is 0 degree, 30 degree, 60 degree up to 360 degree. And we have been instructed to use one decimal place for all trigonometrical ratios. That means that whatever we get the value of our trigonometric ratio, we have to approximate it to one decimal place. Now, these are the values of x ranging from 0 to 360 degree. That is 0, 30, 360, 90, 120, and so on up to 360 degrees. Now, these are the value of cos x. Cos 0 is 1, cos 30 is 0.9, cos 60 is 0.5, 90 is 0, cos 120 is minus 0.5, cos 150 is minus 0.9. Remember that these are to one decimal place. If you check the values of all these trigonometrical ratios in your four figures table, you get the values and you approximate the value to one decimal place. Now let us go to 180 minus 1, 210 minus 0.29, 240 minus 0.5, 270 is 0, that is cos 270 is 0. And we have cos 300 degree as 0.5. We have cos 330 degree as 0.9, and we have cos 360 degree as 1. Remember that all these values are to one decimal place, and since we have been given here that y equals to cos x, that is y equals to cos x, then it simply means that whatever we get for cos x will be the value of y. Cos 0 degree is 1, therefore y is 1. Cos 30 degree is 0.9, therefore y is 0.9. Cos 60 degree is 0.5, therefore y equals to 0.5. Cos 90 is 0, therefore y equals to 0. Cos 120 degree is minus 0.5, therefore y equals to minus 0.5. And so on till we get to 360 degree. In fact, cos 180 degree here is minus 1, and y is also equal to minus 1. We can do the same thing to construct a table for y equals to sine x. For example, we have this x again up to 360 degree at 30 degree interval. Then sine 0 degree is 0. And y equals to sine x. So if y equals to sine x and sine 0 degree is 0, therefore y equals to 0. Sine 30 degree is 0.5, therefore y is also equal to 0.5. Sine 60 degree is 0.9, therefore y equals to 0.9. Sine 90 degree is 1, therefore y equals to 1. We go on and on and on until we get to 360 degree. For example, sine 360 degree is 0, therefore y equals to 0. Here, sine 270 degree is minus 1, y equals to minus 1. So that is how the table is being constructed. Graphs for y equals to cos x and y equals to sine x separately, but on the same axis. we are going to choose the value of y on, we are going to choose the scale on y-axis to be 4 centimeter equals to 1 unit, and on x-axis as 1 centimeter equals to 30 degree. If 4 centimeter represent 1 unit, it means that we are having 20 small boxes representing 1 unit. So counting from here, in between these two thick lines of the graph, you have 1, 2, 3, 4, 5. It means that each centimeter is having 5 small boxes. Therefore, 4 centimeter will have 20 small boxes. So 20 small boxes will represent 1 unit. It means that 10 small boxes will represent 0.5 units. That is on y-axis. And on x-axis, if 1 centimeter represents 30 degree, it simply means that 5 small boxes representing 30 degree. Therefore, each small box will represent 6 degrees. So let us have our table here again. We are copying our table here. This value of x as we have got in the previous slide. Then we have our value of sine x as we have got in the first slide. These are the value of cos x and these are the value of sine x. So the value of cos x are put in blue color for ease of identification, while the value of sine x are put in pink color for easy identification. So let us have our axis. We draw our y-axis here and we calibrate it. Then we draw our x-axis also and we have to calibrate that as well. That means you have to divide them into sections. If you see this calibration, I have checked the values of cos x and sin x on the table. I've seen that the maximum value I have for sin x and cos x are 1. And that is why we have 1, 2, 3, 4. So this is where we have our 1 unit. 4 centimeter represents 1 unit. And here, if you look at it, you see that this is 0.5, which is in between this and this. And here, so we have put the value of 0.9 there. Remember that we are having 20 small boxes representing 1 unit. So it simply means that each small box, let us see here, if there is 0.5 here, 0.6, 0.7, 0.8, 0.9 here. So we can have our values. We can have our values to be plotted. So these are what we have here. And for x as well, we can have our values. We can have our values up to 360 degrees. Then we are going to plot this point first. When remember that y is representing cos x and y is also representing sin x in the two equations, we only want to see how we can solve the equations with with graphs, using simultaneous equation and graphical solution to simultaneous equations. So here, these are value we are going to plot for cos x first. That's y equals to cos x. So when x is 0, y equals to 1. When x is 0, y equals to 1. This is x is 0 along this line. So this is where we have 8. Can you see we have plotted it? Then you have x is 30 degree, sin x is x is 30 degree, cos x is 0.9. So this is 30 degree, 0.9. Then the third one, this one is 60 degree and 0.5. This is 0.5 and this is 60 degree. So this is where we plot. And then for cos x, that's for cos 90 degree, which is 0. So it means that it will fall. This is where along x-axis, this is where cos x should be 0. All values of y along the x-axis is 0. So we have it this way. Then we will now go to 120 degree and we have 0.9. We have minus 0.5. So we have minus 0.5 here for cos 120 degree. So this is minus 0.5, this is 0.5, this is 120. So you plot it here. Then you go to 150 degree, and that is minus 0.9. This is 150 degree, and you have minus 0.9 here. So you plot it there. Then 180, you have minus 1. So cos x is minus 1 at 180 degrees. So this is where we have minus 1 and 180 degrees. That's the point they have in common. Then we have 210 and minus 0.5, 210 and minus 0.5. This line for minus 0.5, you can see it clearly. So you have 210 minus 0.9. So cos x is minus 0.9 for 210 degrees. So, and that is why you have it here. Then you have cos 240 degree equals to minus 0.5. This is line for minus 0.5. We are talking of 240 degree now. Recall that all scholars teachers care, and that we are dealing with cos. So all values of cos, or that's all values of cosine between 90 degree up to 270 degree will always be negative, because those are the areas where cosine is negative, and that is why you can get minus for cos x right from 120 up to 240 here. So in between, you can see they are all negative because cos x is negative at the third quadrant, as you have learnt earlier. Then we can now go to 270 degree, and this is 0. So cos x is 0 here, cos 270 degree is 0. 300, you have 0.5. So this 300 and I have 0.5 here. Then you have 330, cos 330 is 0.9. So remember that cos is positive at the fourth quadrant. All scholars teachers care. So you go to 330, this is 0.9. And you go to 360, this is 1. Cos x is 1 when x is 360 degrees. So you can see the curve again. So you can plot it, and we have this. Can you see the curve? So we have been able to plot the graph of y equals to cos x. We can now plot for sine x again. So when x is 0 degree, sine x is 0. So it means that the origin, this is where y and x are 0. This is where we have this. So we're going to have our sine x equals to 0 here. Then here, 30 degree and sine x is 0.5. 30 degree sine x is 0.5. And for 60 degree sine x, for 60 degree sine x is supposed to be 0.866. But because we are asked to put it in one decimal place, we approximate it as 0.9. So we're going to have our sine 60 degree as 0.9 here. Then we're going to have for 90 degree, this is where sine x is maximum at 90 degree. So we're going to have this, it is here. Then at 120 degrees, 0.9 again. So we come here. And 150 degree, for 150 degree, we have here. For 180 degree, sine 180 degree is 0. And remember, all scholars teachers care that sine is only positive in the first quadrant. So in the first and second quadrant, sine x is positive. Then at 180 to 360 degree, so between 180 and 360 degree, sine x is negative. And that is why we can get this value all here, because sine is negative in the third and fourth quadrant. All scholars teachers care. So you go to 210 and you have minus 0.5 here for sine x. So this is it. And for 240 degree, you have 0.9. And so that 0.9 is here for 240 degree. And for 270 degree, so we have sine x being minimal again at that is at minus 1. So which is the minimum point for sine x. So you have it here. Then you have minus 0.9 when when it is 300 degree, sine x is minus 0.9. So you have this here. And therefore 330, that's for 330 degree, you have minus 0.5 again here. And then you have 360, sine 360 equals to 0. So the last point is here. So having got this plot, we can plot the graph of sine x again, either starting from here or starting from here. But I'm going to start from 360 and end at 0, just this way. Can you get that? Now from here, let us identify the point of intersection. We have one here and we have one here. These are the two areas where the two graphs cut, and those 2 points, the value we are able to get at those 2 points, that is this place and this place, the two values we are able to get there will be the solution to the simultaneous equation y equals to cos x and y equals to sine x. So we can write from to know where it touches on x-axis and where it touches on y-axis. We can just draw a dotted line or a broken line to indicate along this line. That's from here down here. So from here down here, you have this, and you now trace from this point now to y-axis to get the value at the y-axis. So it's reaching this place. And when you look at this, if this is, we know two small boxes represent 0.1 unit on y-axis. If you divide 20 by, if you divide 1 unit by 20, it means that you have 0.2 for each small box. So if this is 0.6, we have if this is 0.5, we have 0.6 here, we have 0.7 here. You can see that this thing is just a little above 0.7 here. So our value is almost 0.7. The next, if you leave this place now to this place, we are supposed to have 0.75. But because this value is too close, so it's better we take an approximate value of 0.7 here. So it therefore means that this place should be 0.7. Let us look at what happened here also at the second point of intersection. It means that before we go to this, so we said that this one is almost at 0.7 here, meaning that the first value of y is 0. The first value of y here is 0.7. And then that when y equals to 0, and the angle, if you trace the angle here, H is representing you can see that this is just taking almost half in between 360, in between 30° and 60°. If you say, I have two small boxes before the line from 60°, I have two small boxes before the line from 30°, so the line has now divided them into two. So, which is the average of the 2 points, and it means that this angle here will be what? 45°. Now, if that is 45°, so it means that the first value is that when when x equals to 45°, y is giving us 0.7. So let us now try and check what happens here. So we draw a dotted line also to reach this place and trace it to y-axis. So I trace it to y-axis. Yes, we have traced it to y-axis, and you see that is almost, when you look at this minus 0.5, minus 0.6, minus 0.7, is also almost at minus 0.7 here. So in that case, you now reach the value of x here. You can see that this is also cutting almost in between 210 and 240°. Looking at the average of the 2 points, you are having 225. So therefore, our solution will be that y equals to 0.7 and x equals to 45°. That's the first solution. The second solution is that y equals to minus 0.7 and x equals to 225, as we have got it here. So thank you for learning with us at Scholars Universal School Online. Kindly subscribe to our YouTube channel. Remember to have this assignment. You have to, in the graph which you have just watched, you have to write the point of intersection which I have told you, y equals to 0.7 and x equals to 45°. And the second one, y equals to minus 0.7 and x equals to 225°. Thank you for listening to Scholars Universal School Online. Till we meet again, God bless you.